Once again, the reading material is Parapsychology by Richard S. Broughton. Picking up where we left off, the next section is PK through the time barrier. Back in his apartment, Sean Sassoon-Hearst, Lalsingh, Harribance, remembered that he was to do an experiment for Helmut Schmidt. This was as good a time as any, so he sat down on the living room floor, closed his eyes, and meditated a bit to get relaxed. Then he reached for the audio cassette tape that Schmidt had given him and popped it into the player. For the last several nights, when he remembered, Sean had been spending 15 or 20 minutes with the latest of Schmidt's PK experiments. Sean had already tried his hand, or mind as the case may be, with the light ring experiment that Schmidt had started using the year before, and he had been pretty successful with it. Now, Schmidt had designed a take-home PK test. Sean was the first to try it. What Sean heard on the tape were clicks. Strong, loud ones, and weak, faint ones, coming at a rate of 20 per second. At that rate, he could barely distinguish the individual clicks. His task was to concentrate on the weak clicks and make more of them come out of the player. Ignore the strong clicks. Push for more weak clicks, Schmidt had explained. Come on, weak clicks, Sean thought to himself. The routine was 10 seconds of clicks, followed by 20 seconds of quiet. Sean listened to this for about 10 minutes, then paused the recorder to get himself a drink. Comfortable again, he resumed listening to the tape. After another 5 minutes or so, Sean found his concentration wandering. Time to quit, he thought to himself. That was one thing that Schmidt had emphasized. Don't let yourself get tired or bored. So Sean stopped the machine and carefully removed the cassette so that he could take up where he left off when next the mood hit him. If you are wondering what sort of PK test this is, you can bet that Sean was wondering too. He knew the researchers over at the Institute for Parapsychology had some pretty crazy notions, but he was willing to humor them and apply his abilities where asked. This experiment was stranger than usual, though. Strange it may well have seemed to the subjects. To Schmidt's fellow parapsychologists, it was nothing short of mind-boggling. Schmidt was attempting to demonstrate that PK effects could go backward in time. In other words, a subject's subconscious intention today could influence the operation of an RNG yesterday. Whether or not he realized it, Sean was actually trying to influence an RNG that had been run the week before. This seems even too wild for science fiction novels, but is it impossible? Surprisingly, not at all. In fact, Schmidt has been so successful with this type of PK that it forms the basis of his principal research programs today. To understand this important line of research, let us examine typical features of a time-displaced PK experiment based primarily on the experiment in which Sean had participated. Schmidt decided to do an experiment of 20,100 binary RNG trials, zeros and ones, grouped in runs of 201 trials. The odd number facilitates later classifying the run as a hit run, more than half the trials, if more than half the trials are hits, or a miss run, if more than half are misses. In this experiment, the zeros and ones are presented to the subject in the form of clicks, delivered to either the left ear or the right ear, depending on whether the RNG produces a 0 or a 1 via stereo headphones. Since Sean did not have a stereo at the time, his clicks were converted into weak and strong clicks on a monophonic player. Up to this point, the experiment is simply a variation on Schmidt's ring experiment. The only difference is that the RNG is connected to an audio device to produce clicks instead of light circuitry. The next step is where the experiment takes a decidedly different turn. Schmidt runs the RNG in the planned manner, but the runs of 201 clicks are recorded on an audio cassette without anyone listening to the clicks or otherwise knowing the RNG output. The significance of the last requirement will be made clear later. Later, again without anyone listening to it, a copy of the tape is made to use with the subject. The master copy is locked away. Of course, while preparing the cassette, Schmidt also intersperses control tests to ensure that the RNG is producing equal quantities of zeros and ones. When the subject comes in, which could be any time from a couple of days to several weeks later, he's asked to listen to the clicks and make more of them come in the right ear. To veterans of Schmidt's experiments, this seems like a straightforward PK task. In fact, often subjects are unaware that they are not listening to the output of an RNG directly, but rather to a pre-recorded cassette tape of RNG output. Sean, of course, knew that the RNG had been recorded because he had taken the tape home. Letting the subject do the tests at home does not violate experimental security in this design, since the evaluation of results is based on the master tapes, which are held securely at the lab. What is the subject expected to do, you might ask? Change the sounds on the cassette tape? No, this is not what Schmidt expects to happen, and that is another reason why he keeps a duplicate tape hidden away, to be able to compare the two and make sure that nothing was changed on the experimental copy. If subjects are able to affect the clicks, somehow they have been able to use PK backward in time to affect the RNG when it was generating the clicks. So much for the example. Was Schmidt able to get subjects to succeed in actual experiments? He certainly did. In his first few experiments of this type, reported in 1976, quite a number of subjects were able to demonstrate PK via pre-recorded targets. Schmidt prepared 6 pairs of cassette tapes, as described above. Sean listened to 3 of the tapes at home. In order to provide a different kind of feedback, the remaining 3 tapes were fed through an instrument that translated the signals into the movement of a needle on a dial, either left or right, rather than loud or weak clicks. Schmidt evaluated the experiment in terms of the number of runs, blocks in Schmidt's terminology, that contained more ones than zeros. Of the 832 runs, 54.6% showed more ones, yielding significant odds against chance of 100 to 1. Schmidt conducted 2 additional pilot studies using a 4-state RNG that produces 1, 2, 3, 4, that recorded trials on punched paper tape. The subject's task, when he came in later, was to make one particular lamp of 4 on a display panel light up each time he pressed the button. In this study, the button simply activated the paper tape reader, which read the next hole in the tape to determine which lamp to light. Both experiments employed special subjects, and both were successful. Since the paper tapes contained many more trials than were actually used, Schmidt also examined all of the unused trials. They averaged around the expected 25%. Only the trials that had been presented to the subjects had the desired deviation from chance. Schmidt's formal experiments to confirm these time-displaced PK effects involved a complicated RNG arrangement that we will not bother to describe here, but the task amounted to listening to clicks in such a way that a PK effect would shorten the waiting time between them. A pilot experiment confirmed that subjects could do the task in real time, that is, trials coming directly from the RNG. And subsequent experiments not only confirmed the real-time PK effect, but also demonstrated an effect of almost equal magnitude for trials that were pre-recorded. Each of the 3 formal experiments yielded results with odds against chance of better than 1,000 to 1. For the pre-recorded trials, Schmidt actually generated the trials in paired sets, A and B. Whether the A set or the B set was presented to the subject depended on a complex mathematical calculation performed just before the test session. Thus, Schmidt himself did not know which trials would be the test trials until moments before the subject worked on them, and could not even inadvertently bias the results by selecting the better set of trials. The unused control trials, as before, gave results very close to those expected by chance. As if that were not enough, Schmidt's 1976 report included another time-displaced PK experiment. This one used a binary RNG that displayed an average output on an instrument needle. The subject's task was to keep the needle deflected left as long as possible. Real-time trials were alternated with pre-recorded trials, and the subject could not tell them apart. In this experiment, however, the pre-recorded trials were presented to the subject 4 times. Without realizing it, the subject made one attempt to exert their PK over the real-time targets, and 4 attempts on the pre-recorded targets. The 30 subjects who participated averaged 50.82% for the real-time targets and 52.9% for the 4 times presented targets. Both results were statistically significant, and although the repeated targets did not quite achieve a 4-fold increase, the results certainly suggested that it might be possible to magnify PK effects with repeated presentations. The next section is named, "But is it still PK?" By now you may be asking yourself if Schmidt is experimenting with PK as we commonly understand it. His time-displaced PK experiments seem a long way from table levitation and even spoon bending. Are we really dealing with the same phenomenon? Quite frankly, parapsychologists are not sure. On the surface, micro-PK looks like traditional PK, only with a smaller target. A subject is asked to cause a change in a physical system using only mental effort, and subsequently a change is observed. By all appearances, the micro-PK subject has been able to cause an action at a distance, which is one of the traditional definitions of PK. The difference in targets, however, is more than just one of size. In traditional PK, the objects that are apparently being moved are large ordinary objects governed by the deterministic rules of Newtonian physics. The targets objects to which Kalagina directs her PK efforts are stable, normally unmoving objects. Without external force, or PK, they would remain just where they are for a long time. In micro-PK, on the other hand, the atomic particles at the heart of the RNG are governed by the probabilistic laws of quantum theory. The target of micro-PK thus becomes nature's purest chance processes. What we are seeing in the results of micro-PK research is not objects moving, but the changing of probabilities of events in systems based on pure chance processes. In other words, the micro-PK subjects are not so much shifting things around as they are shifting the odds of an event occurring. Typically in Schmidt's binary PK experiments, groups of individuals can shift probabilities from 50% to between 51 and 52%. Certain individuals have managed over 54%. This may not seem like very much, but that it is happening at all raises some very fundamental issues for quantum theory. Many readers will already be familiar with the profound changes in our thinking about subatomic processes that quantum theory has wrought. The most basic dictum of quantum mechanics is that one cannot observe a subatomic event without changing it in the process. Since we generally associate observing a system, taking measurements on it, with the conscious attention of the human being who is doing the measuring, some physicists have claimed that consciousness itself must be part of the quantum process. The role that consciousness plays in quantum physics is one of the burning issues in physics today, and Schmidt's time-displaced PK experiments bring parapsychology face to face with that issue. According to quantum theory, the atomic events that are governed by quantum mechanics do not exist as single discrete events until they are measured. Whether a photon will appear as a particle or part of a wave, two mutually exclusive alternatives, is not determined until it is actually measured. It is not the case that prior to measurement the electron really is a wave or a particle, but we do not know which. The way a gift really is a particular object, but remains unknown until we open it. It is not even as if reality were rapidly alternating between possibilities. Neither the particle nor the wave exists as such. The electron, prior to measurement, is considered the sum of the probabilities of all possible outcomes. This sum of probabilities is known as the state vector, and upon measurement, the state vector that describes all possible states collapses to a single state, the one that is observed, while all the other possibilities immediately assume a probability of 0. This strange way of looking at the world of atomic particles cannot be blamed on parapsychology. It is fundamental to contemporary physics, and though counterintuitive to the non-physicist, it is a very successful scientific picture of the subatomic world. Obviously, we do not live in a world where objects are sums of probabilities. A chair is a chair, and we can sit in it without fearing it will mutate into something else when we are not observing it. How does the transition between the odd world of quantum events, which lies at the heart of all matter, and the everyday world of Newtonian physics take place? The act of measurement is a critical issue for this question, and is precisely here that we find a number of diverging interpretations. The interpretations become especially controversial when they try to explain how atomic events interact with macroscopic systems. The standard interpretation of quantum mechanics does not distinguish between a measuring device that makes a macroscopic record of the event, such as a tape recorder, and the observation of a human being. Either should collapse the state vector and fix reality. However, quite a few leading physicists venture so far as to say that mere measurements by a machine is not enough. Conscious observation must be there to bring about state vector collapse. This interpretation of quantum theory would say that Schmidt's pre-recorded but yet unobserved tapes do not have a succession of right and left clicks on them. Until they are observed by a conscious person listening to them, each click event exists as a sum or superposition of the probability of a right click plus the probability of a left click. Until observation, the clicks simply do not exist as discrete events. Remember that this can only be possible because the source of the clicks is a pure chance process governed by quantum mechanics. Schmidt and other physicists who study parapsychology believe that it is in the process of observation that the subject exerts a PK effect by producing a slight change in the conventional, or without PK, probabilities for the events. The observer is, quite literally, helping specify the reality that he or she will see. This, of course, goes beyond the usual interpretation of quantum theory. Standard interpretations permit the observing subject to collapse the state vector to a unique event, but not to help specify what event that will be. Yet, as the evidence from micro-PK experiments mounts, conventional physics may yet have to come to terms with this possibility. According to the state vector collapse interpretation of micro-PK findings, the subject is not actually going back in time, as it were, to affect a past event. The event simply does not exist as a specific outcome until it is observed. It follows from this view that the psychological conditions, the motivation, expectancy, and so on, for the subject at the time of the observation will be salient. They will affect the strength of the PK effect, whatever the subject or the experimenter may be feeling when the RNG is generating. The target is probably unimportant, according to this view. It also follows that if another person observes the results before the PK subject has an opportunity to work on them, then a PK effect may be diminished or even eliminated. In fact, Schmidt recently reported an experiment to test exactly that. He had two subjects, one with a history of success in PK experiments and one with no apparent PK ability, make consecutive attempts to influence the same pre-recorded events. The runs that the PK subject was the first to see produced a highly significant above-chance score, whereas those runs that the PK subject saw only after the control subject had seen them produced only non-significant below-chance scores. It is too soon to propose a precise mechanism by which micro-PK effects might be introduced into the state vector collapse, but the interpretation so far suggests that it may be an informational process, sort of a reverse ESP. The way that one would help select a single event among various alternatives is to add some information into the system. If you have two alternatives, it would require just one item or bit of information to specify a single event, the bit that says that one. If you have four possibilities, as in the 4-button experiment mentioned earlier, it would take 2 bits to pick a single event, one to say greater than 2 and another bit to decide between 3 and 4, for example. Thus, instead of being a force that pushes or pulls atomic particles around, micro-PK may prove to be the type of information flow directly from the consciousness of the observer to the collapsing state vector. And there's a note at the bottom that says, this view stems largely from the work of Evan Harris Walker, a theoretical physicist with the U.S. Army Ballistics Testing Laboratories in Aberdeen, Maryland. His theories have been instrumental in suggesting a framework for understanding psi phenomena, and we shall return to them in Part 3. What about macro-PK, the directly observable movements? Can one levitate tables with information? Well, the speculations described above have not extended beyond micro-PK, but they do imply that we might be dealing with two separate phenomena if macro-PK phenomena are genuine. The largely anecdotal status of macro PK has given the micro PK theorists reason to ignore it for the time being. One may, of course, note that even a table is ultimately composed of atoms, but in order to shift all those atoms 1 foot up, say, one would require an infinite improbability generator, and that has not been found outside of The Hitchhiker's Guide to the Galaxy. More sober appraisals do concede that it would be difficult to extend a state vector collapse interpretation of PK to macro PK effects. Tumbling dice experiments and other PK experiments that involve moving systems can be incorporated into the micro PK model because the act of tumbling may introduce sufficient quantum mechanical uncertainty into the system to permit it to be considered a truly random process. As we discussed earlier, in much of the micro PK research, it is difficult to determine whether the subject is demonstrating PK or precognition. Does the subject influence the random process, or does he somehow see into the future so as to know when to press the button or start the sequence of trials to get the best results? In real-time PK, we simply cannot tell, but when we consider the time-displaced PK experiments, the precognition interpretation begins to look a little less plausible. For some of those experiments, a precognition interpretation requires that the experimenter, who would have had to be the true subject, precognize the entire course of the experiment and thus know the best time to start the recording, the RNG sequence, to match the rest of the operations in such a way as to produce good results. Schmidt's most recent work with multiple observers further weakens, though does not rule out, precognition as an explanation. As this and similar micro-PK research continues, the precognition interpretation becomes less tenable, though the final verdict may be some time off yet. The next section is PK to Confound the Critics. And again, the book is Parapsychology, Controversial Science by Richard S. Broughton. There are links below in the description to pick up your own copy. It is super cheap. Probably going to cost you $4 if it's still the same price, but still very, very cheap if you want to pick up your own copy. Thanks again to everybody watching. I hope you're finding it still interesting.